Today, we are going to focus on how to write word equations. So we are going to take words or names, chemical names, and change them into a balanced equation. There are a couple of things that we need to understand in order to make this process a little bit easier. First, we need to understand what it means to be a diatomic molecule. A diatomic molecule is a molecule that does not stand alone. So for example, when we say oxygen, like the oxygen we breathe, that oxygen is O2. It is not just O. We don't find oxygen hanging out by itself. It always exists as O2. So there are 7 molecules that are like this: H2, O2, N2, Cl2, F2, I2, and Br2. There are a couple of easy ways to remember this. If you have them laid out the way I have them written, they spell the goofy word Hankelfibber. So if you can remember, these are your Hankelfibbers. Another way to remember them they are the Brinkelhoffs, depending on how you lay them out. Now you can also remember your diatomic molecules from their location on the periodic table. There are 7 diatomic molecules, and they conveniently make the number 7 on the periodic table. If we start here with nitrogen and follow it over, these molecules, N, O, F, Cl, Br, and I, always exist paired to themselves when they are in their elemental form. The only one that we need to remember that is not really a part of the rest is hydrogen. So if you can remember, there are 7 diatomics, they make the number 7 on the periodic table. In addition, we have hydrogen over here, which is included. All right, so when we have an equation written out in words, we have to remember that stability is first and foremost. So all of the molecules and all of the elements need to be stable before we worry about balancing the equation. So let's start out by identifying if we have an element or if we have a compound. Here I have aluminum chloride. Aluminum chloride is a compound because it contains 2 or more elements. So I am going to write the symbol and write the charge. Aluminum is a metal and chlorine is a nonmetal, meaning it's an ionic compound. So we know that aluminum is +3 and chlorine is -1. The lowest common multiple between them is 3. So in order for aluminum and chlorine to be stable together, we need AlCl3. As soon as you see reacts with, this is an indicator that we have another reactant or starting material. That starting material is oxygen. Notice that oxygen is not paired with any other elements, so if it is in its elemental form, we're going to write the symbol, and then we have to determine if it is one of our 7 diatomic molecules. Oxygen is on our list of diatomics, so we know that it will only be happy or stable when it's O2. Then we see the words to form or to produce. As soon as we see those words, that indicates that we are moving over to the product side of the reaction. We always separate the reactants and the products with an arrow. Then the first substance that we form is aluminum oxide. Again, aluminum oxide is a compound, so we have to make sure that compound is happy or stable. In order to do that, we're going to check the charges. Aluminum is +3, and oxygen, when it is in a compound, is -2. Notice this time I don't care if the oxygen is diatomic or not because it's part of a compound. And when it's part of a compound, in order to be stable, the charges have to zero out. 3 and 2 fit evenly into 6. That means that I am going to need 2 aluminums and 3 oxygens. Now that that is stable, I'm going to move on to the next substance. I see an and here, which indicates that I have a second product. I'm going to show that with a plus sign. I need to separate 2 or more reactants or 2 or more products with a plus sign. Then I'm making chlorine gas. The only element present here is chlorine. So when you have an element standing alone, you need to check to see if it's on the diatomic list. Chlorine is diatomic, so I know that it will exist as Cl2. Your first job is to make sure that all of the elements and the compounds are stable. We know that compounds are stable when their charges zero out. We know that elements are stable if we have checked to see if they are on our diatomic list or not. Now that everybody's stable, now I'm ready to balance the equation. Stability first, balancing second. So we need to make sure that mass is conserved. So we need to make sure that we have the same number of each atom on both sides. If you're not sure how to write a balanced equation, please check out my earlier video that's linked above that'll show tips and tricks for this. I've listed the number of atoms of aluminum, chlorine, and oxygen going into the reaction on the reactant side and coming out on the product side. I now need to make sure that the same number of atoms that went in came back out, so I'm going to balance the equation. At this point, I can no longer touch the subscripts. The subscripts are there for stability purposes and everybody's stable, so that means they need to stay just the way they are. My only option at this point is to put coefficients out front to make sure that all of the atoms are accounted for. It does not matter where you start when you're balancing. I'm going to start by fixing my aluminums. I have 2 aluminums going in now and 6 chlorines going in. My aluminums are fixed, but my chlorines are not. In order to fix my chlorines, I'm going to need to put a coefficient of 3 here. Again, we can't change subscripts after everybody's stable. That's going to give me the 6 chlorines that I need. Now I'm down to my oxygens. So my oxygens do not match, but there's not an easy fix. The lowest common multiple between these two is 6. So I can get to 6 oxygens by putting a 2 here. That 2 distributes through to give me 4 aluminums and 6 oxygens. Now, when I go back to the other side, I can fix my oxygens by putting a 3 here to give me the 6 oxygens I need. Now everything matches except for my aluminums. So although I put a 2 there as my coefficient to begin with, that 2 does no longer work because I need 4 aluminums to come out. The only way I can fix that is by putting a 4 here. When I put a 4 in front, that gives me the 4 aluminums that I need, and it then gives me 12 chlorines. Everything matches except for my chlorines, so now I'm going to go back over to the other side. I'm going to get rid of the 3 that I had there, and if I want 12 chlorines, that means I'm going to need a 6 there. Now it is a balanced equation. So remember that you have to start by first making sure everybody's stable, and second, making sure that all of the atoms that went into the reaction come back out. All right, let's look at another example. This time we have iron 3 nitrate reacting with potassium sulfate to produce iron 3 sulfate and potassium nitrate. We're again going to start by identifying if we have an element or a compound. So iron nitrate is a compound because it has 2 or more elements in it. We're going to write the symbol and write the charge. I know the charge is +3 from the Roman numeral, and nitrate is a polyatomic ion with a charge of -1. This is not stable at the moment, so your job is to make every compound stable. FeNO3, 3. Don't forget the parentheses around the polyatomic ion when you have more than one. Then I see reacts with. That means that I need a plus sign. There's more than one reactant here, and my second reactant is potassium sulfate. Potassium is K with a +1 charge, and sulfate is a polyatomic ion, SO4, with a -2 charge. In order to make that stable or happy, we have to zero out the charges, making this K2SO4. Then I see the words to produce. As soon as I see the words to produce, that means that I'm moving over to the product side of the reaction. I indicate that with an arrow, and then I have my first product, which is a compound. I know it's a compound because it has 2 or more elements in it. When I have a compound, I have to make it stable by zeroing it out. My iron has a +3 charge and my sulfate has a -2 charge. In order to be stable, I am going to need 2 Fe's and 3 SO4s. This and indicates that there's a second product. I'm going to put a plus sign there to separate the 2 products. And then I have potassium nitrate, yet another compound. Because it's a compound, I am going to have to check the charges and make sure that they zero out. K is +1, the polyatomic NO3 is -1. This is stable as KNO3. Your first job is stability always. Once everybody is stable, then you're going to go through and you are going to add coefficients to make sure that no atoms are created or destroyed throughout the course of the reaction. One way to speed up balancing an equation is to keep your polyatomic ions together rather than breaking them up into their individual elements. This will work as long as the polyatomic goes in and comes back out of the equation intact. So I'm going to use that strategy. If you prefer to break them into their pieces, into their N's and O's and S's, that's totally fine as well. But we see that we have 1 Fe, 3 nitrates, 2 potassiums, and 1 sulfate on the reactant side. When I go over to the product side, I have 2 Fe's, I have 1 NO3, 1 K, and 3 SO4s. It does not matter where you start, but we are going to start to fix the missing elements using coefficients. I'm going to put a 2 in front of my iron. That 2 distributes all the way through, so I'm going to change my list to reflect that. I have 2 Fe's, and I now have 6 NO3s. I fixed my Fe's, but my NO3s no longer match. I can fix my NO3s by putting a 6 in front. That's going to distribute all the way through, so I have 6 K's and 6 NO3s. Now I need to fix my K's. If 6 atoms came out, 6 had to go in. The only way I can have 6 go in is by putting a coefficient of 3 there, giving me 6 K's and 3 SO4s. Now that they both match, I have a correctly balanced equation. So the key is to make sure stability first, that everybody's zeroed out and happy. Second, to make sure that all of the atoms are accounted for by balancing the equation with coefficients. Let's look at one last example together. Water decomposes to form hydrogen gas and oxygen gas. So we're going to start by identifying my reactants. I have water. The formula for water is H2O. That's already stable, already happy. That water decomposes to form. As soon as I see to form, I know that I'm going over to the product side, and I'm going to indicate that with an arrow in my balanced equation. Then I form hydrogen gas. Notice it is just hydrogen. Hydrogen is not paired up with any other elements. When I have an element, I need to check to see if it's on the diatomic list. Hydrogen is indeed on the diatomic list, so I'm going to put a 2 there. That is the only way that hydrogen will be stable when it's standing alone. The and indicates that I have a second product, so I'm going to show a plus sign. And oxygen is the second product. My oxygen gas, notice it's just oxygen, so it's not paired with any other elements. When I have an element standing alone, I have to check that diatomic list, and O is on the diatomic list, indicating that in order to be stable, it has to exist as O2. Now that everybody is happy or stable, now I'm ready to balance. I'm going to start by counting my atoms that go in. On the reactant side, I have 2 hydrogens and 1 oxygen. On the product side, I have 2 hydrogens and 2 oxygens. So we can't create or destroy matter, so we have a problem here. One of our oxygens seems to have appeared out of nowhere. So we know that can't happen. The only way to fix it at this point is to fix it with coefficients. We cannot change subscripts once everybody is stable or happy. So I'm going to put a coefficient of 2 out front. Remember that multiplies all the way through, giving me 4 hydrogens and 2 oxygens. My oxygens are fixed, but in the process, it messed up my hydrogens. So I'm going to need to put a 2 in front of my hydrogens. This is now a correctly balanced formula because everybody is stable and all of the atoms that went into the reaction came back out. I hope this helped clear up how to take words and write them into a balanced equation. Thanks for watching, and please check out my other videos.